this one shouldn't really take a lot of time. DHCP is a pretty straightforward protocol. It's a broadcast protocol. So troubleshooting the DHCP broadcast protocol is like it either works or it doesn't work. And we had the issue, I had the issue when we were doing the core installs, DHCP just kind of quit. Actually, networking kind of quit on my machine, and I probably did that to myself. But DHCP, once it's there. You can, and one of the big deal things I think to understand, realize is that you can bind DHCP only to particular NICs if you want to. The other thing, when you get ready to do this chapter, and in the lab sheet, there's a little instruction. Before you start, shut down your computer and add the second NIC. There is a second NIC that's available, and put it on the 192.168.100 network. I know the book uses the 192.168.100 network. That's only a coincidence for their stuff. We're using the 192.168.2 network for all of our addressing, for our actual addressing, because that's the one that I've got set up to route when you need to get out of the virtual network. When you do the labs, keep in mind that DHCP is a broadcast protocol. So like one of you at a time can actually confirm that your DHCP is working, and once you get it working, deactivate your scope. PEG classes do some really strange stuff when we were using the physical machines. Add DHCP, don't activate the scope, leave the scope on. We gave the whole network one night a lot of 192.168 addresses, and they couldn't go anywhere. So that's one of the, I guess, things that hackers kind of try to do at times, is to put in a rogue DHCP server, and we'll talk about those, and we'll talk about authorizing DHCP in Active Directory, and all that's really, really cool as long as you can talk all your hackers into using Windows servers. If they go out and use a Linux server or a third-party software or something to give addresses, then Active Directory can't protect you. But back to the point that it is a broadcast protocol, if you have, put this little plug in, broken your network up into a lot of different networks, then you can save yourself, because you'll have a very limited number of machines that it can actually affect. In this network, if we put a DHCP server in here, how many machines would it affect in the building? It's the ones in here, because there's a router between us and everybody else. So that goes back to some of the, what do you want to do in your network planning? What are some of the reasons that you want to put networks in? What are some of the reasons you now want to be able to subnet supernet? All of that comes into play in some of these things that we do, some of the infrastructure. What does the infrastructure look like? What devices do we have? What's the impact of those devices as we do these things? So the objectives, discuss the basics of Dynamic Host Configuration Protocol. And I say, what's DHCP? And some people say, it's the Dynamic Host Configuration Protocol. Okay, I got it. I understand what the letters stand for. But if you think about the names that go through here, dynamic, we can have either dynamic or static, right? Host, a host is some device that can have an IP address. And configuration, and what it really doesn't say in here, dynamic host IP configuration protocol. So what we're doing is configuring the IP characteristics of the machines that get IP addresses or IP information. IPv4 information is what we're really going to go in this thing dynamically. And the Windows default is DHCP, dynamic, automatic. I think this the little radio button says automatically get addresses. And you can configure them for both the IP, and you can configure DNS separately. Not necessarily a good thing to do, but you may need to do that at sometimes. Describe the components and process of DHCP. We'll look at how you get an address, how you renew an address, how long the addresses are good for, how long should the addresses be good for. Cox Cable is always an interesting thing to look at. Cox Cable gives you a 24-hour address. Has to be renewed every 24 hours. Why did they do that? Because that's what they found works for them. What's going to be the lease time, and I know I'm using words that we haven't talked about yet, but we'll get to. Lease time, how long can you keep this address, depends on your network, what happens in your network. If you're in a college library where people come in with their laptops and stay a couple hours and then go away, you probably want a short lease time. If you're in a situation that computers probably should consistently get the same address, maybe like in this building, the desktops, we can have a much longer lease time. So how long do you want them to keep and how many addresses do you have? Those are all things that you need to consider. Install DHCP in a Windows Server 2008 environment. That's just a matter of going and installing the role. And once you get the role installed, it's going to ask you to go through the configurations. Those are all step-by-steps if you need the clicks in the activities in the book. I'm still a fan of, once you kind of get a feel for the way these things work, read the windows. Instead of trying to look and say, oh, should I click here, should I click there? Experiment. That's what some of these labs are for. The click-by-clicks, if you get lost, get confused, need them, take a look at them. But get to the point. You guys have had some experience. You've done 2 Windows classes now, and you should have a pretty good feel for how it does things. And it basically does things, unless it's something that's really outrageous, that the installation wizard itself will tell you what you need to do next. Now, a couple of things that happen. Well, even the WDS server tells you what you need to do next. Man, I know exactly what you need to do then. You go look it up. Oh, yeah, I got to put this DVD in so I can get these things. Configure the DHCP server. This is where sometimes people get into issues, not anything, because it's just not that complex. Issues here, what can be configured. There are some special configurations that we can do with Windows that allows us to do things. And we can set up, we can group computers together so that one group of computers gets something different than another group of computers. Not as easy as it usually says. Administer DHCP on clients and servers. Administer DHCP on clients is really like yes or no. Dynamic or static. That's the only real choice you have on your client machines, isn't it? And that's the only real choice you have on your server machines. And that's the only real choice you have on your switches. And that's the only real choice you have on your printers. There are some times, some cases that you really want to have static addresses, things that always want the same address. They go through, and I'll give my opinion right now as we go through these things. There are sometimes you want statics, and they always want to, when you have statics, servers, for instance, I think should be statics. Printers probably should be statics. DNS servers definitely should be statics because that's the only way you can get there. You can't resolve it until you can find it, and you can't find it if you don't have an IP address. And if it's a dynamic IP address, you never know what it's going to be. There are ways to make DHCP, and we'll talk about that, give it the same address all the time, but why not use statics? What they love to do is say, okay, you have these, now we need to exempt some addresses. Why? Just don't put them in the range that you're giving out. Troubleshoot DHCP. Troubleshoot DHCP is not a very, I don't think, very complex process because it works or it doesn't work. It's on or it's off. It's a broadcast protocol. What can you do with that? The only thing that you could do with that is we do have the capability to install this device called a DHCP relay agent. Get all these terms up front and then we'll talk about them. DHCP relay agent, which relays the request to a server and then gets it back. So we might have a situation that's misconfigured, but broadcast misconfigure is kind of, it's either plugged in, it's not plugged in, the service is working, or the service isn't working. So the basics DHCP, and this is kind of a real shocker, it's a layer 4 protocol. What do you think makes it a layer 4 protocol? What would make it a layer 4 protocol? That's on this slide. Look down at the slides. Look at bullet number 3. Clients use UDP port 68. The port number is, and the only thing that is going to make it layer 4, and the only thing that we have port numbers on is layer 4. So this is a layer 4 protocol. It's a broadcast protocol. Uses UDP, datagrams for communication. UDP, is that important? Could be. What about firewalls and such? What ports? TCP, UDP. You need to know which protocol, which port in order to allow some things to happen. Most routers, by the way, allow, they call it pass-through. What they really do is they become the DHCP relay agent. They'll relay the broadcasts from the router to the DHCP server. Because in this building, do you see a DHCP server in this room? You see a Windows server in this room? I see 1, 2, 3, 4, 5, 20. Actually, not because somebody took one. 20. I was going to say 21, but 20. God, someone back there is gone. 20 workstations. That's it. Anything else you see running in here? But if you look at your IP config /all, what? Oh, I thought you found something. No. The switches are running, but there are no routers in here. There are switches. So how do we get these addresses? If you look at your IP config all, you get a DHCP address. And you get a DHCP address 1060.64.17 or something like that is the DHCP server. It's not on our network. We're 1060.2.11. So how do we get to, in a broadcast, how do we get to a 1060.64 address? Nobody's curious about that? How do we get an address from that? They call it DHCP forwarding, and they have a lot of different terms that they use for this, but what it really, I think, happens is the router becomes what's called a relay agent. It takes your broadcast and then forwards it to the DHCP server as a unicast message. And then the DHCP server sends it back to the router, and then the router broadcasts it back to you, the answers, and we'll look at that process here in a minute. Defined by IRC 2131. If you have never looked at RFCs, and I know it's like, you know, eyes glaze over and all that good stuff, just look at them just to see what's there, if nothing else. They're not written all that technically. It's a description of what happens in the protocol. Clients use port 68 to send and receive DHCP broadcast messages. Servers use port 67 to send and receive DHCP broadcast messages. So port 68 is connecting to 67. The clients use one port and the servers use another port. Is that important? Could be. Some point if, when we're doing the troubleshooting, it ain't working, are the ports available for the broadcast messages if we have firewalls running on the devices themselves. So, nice little graphic here. Source 67, destination 68. The destination is always going to be the port that's open on the other end. And the question that you've heard me ask before is, in web and web's port 80, what port do you go from on your computer to go to port 80? And the answer, I'll answer that one. I'm going to make you do that this morning. But the answer to that one is we don't know. It's called an ephemeral port, some temporary port. These are well-known ports, right? A well-known port, 67 and 68. So on the client machine, the source port is going to be 67. That's identified with DHCP. And the source port, the destination port 68, that's identified with DHCP, the well-known ports, on the well-known ports list. The lease, when you configure your server, and they've done the setup a little bit differently than Windows 2003, because one thing they put DHCP or IPv6 in it. you don't have a real choice for how long the lease time is. You have two choices, either wired or wireless, 8 days or 6 hours. When you get done, you can change all of that. When you get done, you can change all of that like is in the video that's on the Moodle page. That's a Windows 2003 server. Once you get there, the configuration, the changes haven't changed a whole lot. But the lease defines the amount of time or the duration that an IP address is loaned to a DHCP client. What's your lease time on these machines? Go to the command prompt, do an ipconfig/all, and tell me what the server name is and how long the lease is good for. When did you get the lease?
The lease is due this morning at 7:50 a.m.
Yeah.
It expires at 5:44
5:44
p.m.
p.m. So that's about a 12-hour lease, right? No, it's not either. That's a 10-hour lease, isn't it? 7 to 17?
3, 4, 5, yep.
7 to 17, 10-hour lease.
Less than 10 hours.
A little less than 10 hours. What's the IP address of the server? 1060 something or other.
10.60.64.7.
1060.64.7. I said 17. 17 is actually the FTP server. 10.60.1.4. But DNS doesn't really bother us a whole lot because DNS is not a broadcast protocol. The point I was trying to make earlier is DHCP is a broadcast protocol, and you're getting that information from something that's someplace else on a different network. How does a broadcast get past the router? The router has to be configured to allow that. So now we're stacking some of this protocol, putting some of this in with something else. What they're going to say, what we're going to say a little bit later is, oh, we'll configure a Windows server as a DHCP relay agent. That's pretty darned expensive. To put a server in just to be a relay agent, to relay those things, when you can configure your router to actually do that for you. Probably going to be more efficient to use the router. You can use the router as a DHCP server also if you want to do that. So there are other ways to do it. What we need to look at here is the process, how this thing works, how you do the configurations, what they are, what they are. The lease duration, the amount of time the client keeps the IP address before releasing it. That's the absolute limit. The machine itself will try to renew its lease. It's kind of like when you lease an apartment. If you like it, what do you want to do before the lease is up? You want to renew it. Or you get an IP address if you like it, and there's no reason not to like it because they're all about the same, aren't they? Then the machine tries to renew it before the lease is up. And the machine tries to renew it at the 50% point. When the lease time is half over, it asks the DHCP server to renew the lease. And I'll go back to Cox Cable. We have DHCP addresses, and we have DHCP addresses in these things. And if you're really curious, check the IP address of your machine. And then check your IP address the next time you come in and the next time you come in and see if it changes. Cox Cable, your IP address tends to be the same even though it's a DHCP address because at the 50% point, you renew it. If you renew it, it doesn't change. The only reason that it would change is if something changed and you took that address out of the DHCP scope. The scope is the pool of addresses that the DHCP servers can offer. You define that. That goes back to, I think what I said earlier is, and we're going to have some other terms here in a minute called reservations and exemptions from the addressing scheme. But if you're going to have some static addresses, why not just say, instead of starting at the 1 address, let's start at the 50 address, depending on how many static addresses that you need, so that you don't have to worry about the system giving out the addresses that are statically configured. You don't have to worry about saying, no, don't use these. You can have static addresses. You define the scope, however many addresses you want in that scope. This is the address leases when we look at a DHCP server. Actually, let's just look at a DHCP server, because this. Okay, let's see if we can look at a DHCP server. It shows up in the server manager. It also shows up in the administrative tools. This is the one that I've been using to give out addresses for the machines that you've been doing. I see Chris D. Some of these we can recognize. So I can tell which of you have changed the name of your servers and which of you haven't, because most of them are the generated names. Administrator 1. Administrator 1, that's one of those PXE installs, because you have to have Active Directory. Active Directory names them for you, and it names them for the user. The way it's set up names it for the user, and it depends names. Administrator 1, 2, 3, 4, 5, 6, and we have up here to Administrator 6, Administrator 4, if you look in these things. The Win, with all of this stuff after it, are the installs for the fulls. So the addresses that have been given out, we have the client IP address, the name of the machine, lease expiration. They're all 3/7. What's today? Today's 3/7. Because I made these relatively short. You're going to go put static addresses in, and we want these to go away. How long do I want addresses for? Honestly, I found out on the virtual network, the more machines that we get on, I need to make shorter and shorter and shorter leases, because we run out of addresses. You only need the IP address when you're actually working on your machine, so we can make those leases shorter and use actually a smaller pool. I've got a larger pool set aside for statics, because the servers we want to be static addresses. And then I try to have enough there for when we do tests, we can have statics. And you can have, days can have statics, nights can have statics, those things. So we have the IP address, the name, the lease expiration, the type, DHCP. The unique ID here is your MAC address. And then we have network access protection is off, and network access protection is a chapter like in week 4 in DHCP management of it. So we have that address, those address leases. So those addresses are leased. They were released on, they actually were released on yesterday afternoon, probably when the server crashed, and they all got restarted. How long are they good for? And I don't remember. I think I made them good for like, I don't know, 12 hours or 10 hours or something like that. I don't remember when or how long they actually are. But these things get released, or the lease gets done at different times when we look at these things. Let's see if we can get back to the presentation now. Same, right? Their picture and what you actually see, exactly the same, which you would hope would be the case. The process, DHCP options, and when we get done, I want to look at the options a little bit. The IP address, these are the basic options. The IP address, subnet mask, default gateway, primary, secondary, DNS servers, and the DHCP lease expiration. How long are we going to allow these things to be good for? And this is based on the scope. The scope is the IP addresses that were given out using DHCP. So this is the basic information. This is the basic information you need to get from your machine to someplace else that you know, the www.yahoo.com. What do you need? What do you need to be able to get there? You got to have an IP address. You got to have a default gateway to go someplace else. You have to have a subnet mask so that the device knows whether it's local or remote, whether to try to resolve it locally or send it to the router. You got to have a DNS server in order to resolve www.yahoo.com into an IP address so that the routing system can take care of it. And the lease expiration, how long do you get to keep that IP address for? Dynamically assigned IP address. DHCP Reservations, what this does, if we have a machine that's always going to allow you to assign a specific IP address to a DHCP client without statically configuring the device with IP information. Sounds really cool, right? Really good. So we'll just do a reservation for our DNS server instead of giving it a static address. Want to do that? But it works great. What if DHCP goes down? What if the DHCP server quits? Since it's not statically assigned, it's DHCP assigned, it has a reservation, big deal. It still has a lease. When the lease is up, the lease is up. And if it can't renew the lease, reservation or no reservation, then you're done. It's kind of like you make a reservation at a hotel. How long do they hold it for? If you give them a credit card, they'll hold it for longer, but if you don't give them a credit card, when does that reservation expire? Usually at 4 o'clock, right? They'll tell you when it is. But the reservation will expire also just like any other DHCP address. To configure a reservation, you've got to have the MAC address. Why do we have to have the MAC address?
You have to know where the IP is.
Have to know where the IP is going to be associated. It's the only thing that we know when we start these machines up. And what does the computer know when it starts up? Itself. It knows its MAC address. It has no address. That's why broadcast, it can't get anywhere else because it doesn't have anything to be routed with. So it uses the MAC address. When we do a reservation, the IP address that we want assigned to the MAC address that we want to assign. Sounds really good when they just say put in a reservation in here, right? A lot of these things sound really good until you get down to the actual configuration. I got to know a lot of stuff to do that. I was at Blue Ridge, the guy that was there before me had actually gone in and put in reservations for all 400 computers, 450, whatever it was. Is that a good idea? Is that a necessary idea? So also I'll know what names go with the IP addresses. Golly, I thought that's what DNS was for. How about you? Did he need to do that? No. Was it wrong? No. I guess it gives you something to do during the day. I wasn't real wild about that. I just let DNS take care of it. If I needed to know what name went with an IP address, you can go to DNS and figure that one out. So these things do work. All of these different infrastructure services roles do eventually work together, and we'll do DNS next week. These are some of the common options. The numbers, the 3 is the router, 6 DNS. What do we normally configure on these things? Like the router, when you configure the router, that's your default gateway. So associate router and default gateway together when you do these configurations. DNS server, DNS domain name you can put in, not necessary, but it's one of the things that you can do. The time NTP server, if you want to do that, Microsoft uses its own NTP server. You can do other ones, but the NTP is a time server if you want to specify a time server on these things. So there are a number of items that you can configure. Win server, if necessary, if you have a Win server running. Win servers are something that we're trying to get away from, or Microsoft's trying to get away from in the Microsoft world, because the operating system itself should not need a Win server. There are some applications that do need a Win server. We have gotten to the point, and I checked with Chris just before he left, that we've actually turned off our Win server because we no longer have any applications that require it. I think the last thing before the upgrade that actually still used it was the antivirus software. Fully qualified domain names, fully qualified domain names out of the DNS servers where you really want to be in those things. But this is a list of some of the common DHCP options, not all of the DHCP options. When you start doing those options, that list goes on and on and on and on and on. I guess what's handy with the number is that it gives you an idea of how far down you have to go in the list. This is just in the DHCP, and again, this is installed in Server Manager. You have a log, and you can get into it and configure it through Server Manager or through the administrative tools. The communication messages are discover, offer, request, acknowledge, negative, acknowledge, decline. What we do, and I've got a slide that I thought I had maybe right after this one, that kind of goes through the process. DHCP discover when a workstation, server, router, switch. We had an interesting situation years ago, and I always jump into these stories right in the middle of things, right? We got this brand new 3-com switch, so this was a lot of years ago. Put it on the network. Well, it was set up with the old protocol. It's called boot P, which doesn't give up its address. Or that one didn't anyway. And we kept getting a DHCP conflict occasionally. And a DHCP conflict with this address. Well, what the heck's going on? We get this DHCP conflict. Well, after some troubleshooting, and that's one of the troubleshooting things, finally found the device that had that address, and lo and behold, it was that switch, and you couldn't make it go away. So what we wound up doing eventually was going into DHCP and making an exception for that address, take it out of the pool, take it out of the scope, so that that address wasn't offered, because that switch had it, was going to keep it, wasn't going to give it away. Different things that you need to do. But the process, you turn on a computer, or in that case the switch, sends a DHCP discover message, trying to discover a DHCP server. And it sends it from port what? 68. Sends it to port 67. All right? I'll try to get these ports in here. The DHCP server, and if there is more than one DHCP server, we'll say DHCP servers, get that discover. They then send, all of them that get it, send a DHCP offer. If there's more than one DHCP server, the computer's got to make a decision. Got more than one offer. Which is the better IP address? The IP address it picks is whichever one gets there first. Whichever DHCP server answers first is the address that it'll take. So it then sends the client, all the ones on the left here are the client, sends a DHCP request requesting an address from one of the DHCP servers. And then it sends a DHCP acknowledgement that says, yes, you can use that address. So it's a 4-step process. A discover, offer, request, and acknowledgement. A negative acknowledgement, a NAC says no. And the machine can decline an offer, can decline the address. I don't know that you'll see those very often. A NAC, maybe if you took an address out of the pool, then it would be a negative when you try to renew the address. Because once you have the address, it becomes a 2-step process. You have the request and the acknowledgement, or the request and the negative acknowledgement at the 50% point. The other thing I didn't say is at the 87% point, if the DHCP server went offline or can't renew your request, at the 87%, 87.5% I think actually, percent point of the lease time, the machine panics and says, hey, any DHCP server, give me an address. It actually goes back through the discover process. The initial lease, the clients make these requests so they don't have a current lease in the scope. Lease renewals, renewal time and the binding time. The renewal time is the 50%. The binding time is the 87.5%. If we're getting into the terminology. How we get one, the DHCP request, DHCP acknowledgement. This is the renewal process, 2-step process. Yes or no. If it comes back with a NAC, then you've got to go through the discover the whole. Give me an IP address, please. Changing subnets, client moves to a new subnet, can't use its current lease because the IP information doesn't match the new network. it's not going to communicate, because how long does it keep, they're working on the roof, how long does this machine keep that IP address that it's given? The expiration of the lease. Actually, the 50% point when it tries to renew it, right? If it tried to renew it and it keeps renewing it at the 50% point, still trying to renew it. And if it's on a different subnet, if we took a machine, brought a machine in here from the 1062.08 network, what would its address be? Because it would have a lease on it, right? And this, I think, probably is more prevalent with wireless, because you may go from network to network. You go into some place, and what address do you have? Still got the old address. Can you communicate on that network? Shouldn't. Change subnet. So how are we going to get rid of it? Now, this is one that actually could happen to you. I move a machine in and it's got an address that's on the wrong network. How do you get rid of it? IP config, release, and renew. Doesn't happen automatically. You may need to manually release and renew those addresses. This is the one that I thought was early. So we got the discover. Find my little arrows here. The client sends the discover message. You got to watch it because I made it. To the DHCP server. The DHCP server then sends the offer. The client sends the request back, so yeah, I like that address. Can I have it? And then we get the DHCP acknowledgement from the server. My way to remember this, DORA, discover, offer, release, a release request, acknowledge. My way of using this, Dora the Explorer for all you guys with kids. If we did the DHCP request and then we had the DHCP NAC, this would be the renewal. We want to renew our address, and it said no. Then we got to go through the discover, offer, request, and acknowledgement, the whole process again. This is just a graphic that shows what we talked about before. The renewal request is refused for whatever reason. That address got taken out of the pool. Or what's happened here before is, golly, we want to change the whole addressing scheme of the network. And this makes that much easier. We want to go from a 10.60 to a 192.168, let's say, for instance. Could we do that? Would work better if you had, how would you do that? Let's see if we can walk our way through that, because some of the terms that we've talked about. What would you do first? Yeah. I think the first thing I would do is make the lease time really short, because hopefully they're not going to tell you do this in 15 minutes. If they tell you, hey, next week we're going to change the DHCP addressing scheme, let's shorten up our lease time to maybe a few hours. And then we can do what Patrick was saying. We can go into the DHCP server, change the addresses. Probably want to do it over a weekend, so that everything will have a chance to time out, to expire, and then to go through the, no, I don't have it anymore. Can't give it to you if I don't have it, can it? And then you go through the discover, offer, request, and acknowledgement process. What do each of these things in the configuration do? That's what I'm trying to get you to think about, because there are times that you do that. We've had to change the addressing scheme in here, I don't know, since I've been here probably 2 or 3 times for one reason or another. And how to do it? Shorten the lease time, change the DHCP server. It'll take care of the rest of it for you, including registration with DNS if you have older clients. The computers themselves actually register with DNS. And that sometimes it's an issue that those registrations don't get taken out when they should. DHCP v6, DHCP to receive IP addresses and configuration information from an IPv6 router. Routers play a bigger role in IPv6 than they do in IPv4. There are some configurations when you do the initial startup, the DHCP, and you may or may not have noticed when I had that one up, it had an IPv4 and an IPv6 configuration. When you install it, it's going to ask you to do some IPv4 stuff and some IPv6 stuff. Use the numbers that are in there. Actually, I think I give you a little bit other instruction. What I want you to do is everybody do a different scope so that you know when you test it with your core machine that you actually got your address. And if you didn't get your address, then you go to whoever it was and say, turn yours off so I can get my address. Because if we have more than one DHCP server on a network, which address is it going to get? Whichever one answers first. Could be yours, could be Jody's, could be mine. Actually, mine's not on that network, but whichever one answers first is the address it's going to get. Requires configuring your router to forward all auto configuration requests to an available DHCP v6 server. So we can configure this stuff on the server itself, and then again they've got a lab I think to do some of those configurations. But what happens is the workstation and goes to the router, and the router says, "I'll go to the server to get your information." It kind of becomes a relay agent regardless in that case. So have we changed what actually happens? I don't think a lot. Have we changed what we call it? Yeah, auto configuration. Auto configuration, go to this device. The server role, minimal server resources, starts the DHCP server service, installs the files you need, initializes DHCP console on the local system, and goes through a basic configuration setup, and that's what's going to happen when you install this thing. And I don't think any of the activities are going to take that long. I never knew what JET stood for. Now I do. Joint Engine Technology Storage Engine. I just like JET better, don't you? It's a lot easier to remember. This is a database. The database size is based on the number of clients. The database grows unless you actually go in and compact the database. If you've ever used Access, it uses the same technology. A lot of Microsoft databases use the same technology, the joint engine technology. The service role is installed with the server role. The server console is the GUI for managing the addresses on the server 2008. And any of them is going to get a DHCP console to do those things with. Authorizing, this is a big deal in Active Directory with a Windows DHCP server. And I put a link in the resources that says, how does a DHCP server know it's authorized? How does a DHCP server know it's authorized? And this is why yours actually may not start. You can still do the configuration, but it may not start. Because what happens when these machines start up, they use DHCP to find out if they are authorized in Active Directory. If you are a domain member, we can authorize you. What it does is when your server starts up and you join the domain, which I think you have to do in order to make WDS work, right? Which I'm sure you have to do to make WDS work, which is one of the labs you do in like Chapter 1. Does that sound right? Then you should be a member. You should be able to go through the authorization process for your server. So you know how to do that. Otherwise, the service won't start. They say the service won't start. What I've seen actually happens is the service starts up because it says, I'm a service and I'm going to start up. And then it checks, and when it finds out that it's not authorized, it shuts back down. Standalone machine, looks for a standalone, not a member server, a standalone server looks to see if there's an active directory. If there is, its service won't start using the DHCP inform message. That's a short article. Take a look at it. How does a DHCP server know that it's authorized? And why do we care? We had an issue here with some virtual machines in a continuing ed class that somehow, some way, a DHCP server got access to the network up front. The network up front, instead of getting 10.60.61 addresses, we're getting 192.168 some another. That's really tough to do your job when you can't go anywhere. If you have to authorize it, then you're not going to have rogue Windows DHCP servers. Can you have rogue Linux servers? Absolutely. They don't care. They don't care about Active Directory. They'll just start sending addresses. What you can do, and remember if you do ipconfig all, one of the things I want you to look at, you can get the IP address of the server. And what we finally did was get the IP address of the server that was given the addresses, connect to it, turn the service off remotely because we don't know where the heck it was. Turn it off. What's that address? Can you turn it off? Can you disable that address? Where is it? What's it doing to you? What network is it on? That might be handy to know too. Where are these things? So, Active Directory, domains, they have to be authorized, and that's really a toughie. Right-click Authorize. The other thing to understand about who can authorize it is enterprise admins, not domain admins, enterprise admins. Ours gets authorized because we use a Linux DHCP server. But the Server 2008 prompted for credentials during the installation of your server as a member of the domain. And it's, you know, the same password, administrator, capital P, password 1. The domain is 2560 when you do that, the one that we're using. You need to configure it for its initial use. At least one DHCP scope to issue IP addresses, and they tell you what to use. I think I'll tell you what to use too. They have you use a single address. Go ahead and put a scope in just to see what it's like. Instead of, because of the single address you use, the start and the end is the same IP address. You only get a single address. And that way, if somebody else, if you don't disable your scope, somebody can yell at you. 192.168.100. I think I want you to use, I think I ask and do whatever the lab says because it should work out. 100 plus whatever your number is for your server so that everybody's got a different scope that way. And then if you have an issue, you know who to go to and say, would you please deactivate your scope so I can test my DHCP server. All these activities, and you notice they're really fast, really long activities, 5 minutes, 10 minutes, 15 minutes. Nothing takes that long to do in DHCP. And if it doesn't work, honestly, if it doesn't work, like most things, Windows, try a reboot. In my opinion, again opinion, you'll have a lot more success turning it off than just a restart. Because when you start it from the ground up, it loads more stuff new than it does in a restart. Restart is going to keep some things cached. Exclusions we talked about, and this exclusion is things that have the static IP addresses. The switch, and for some odd reason, I guess it was what was available at the time the address was issued, the switch got an address right in the middle of the scope range. So it wasn't like you could just change the scope and say, okay, we'll leave that one out. We had to configure an exclusion, an exemption. Don't use this, don't give this IP address away. At the beginning and end of the scope range, and this is one, and this is back to my opinion, not theirs, obviously, because create exclusionary ranges at the beginning and end of the scope so that you can use static IP addresses. Why not just don't put them in the range? set aside a range of IP addresses, 10, 15, 20, 50, whatever you think you're going to need in that particular subnet. Don't put them in the scope. Then you don't have to worry about exclusions. You don't have to worry about reservations. You don't have to worry about DHCP making a mistake because it won't give those addresses away. But do those activities anyway to create the exclusions. The options quickly and easily provide the DHCP clients with the configuration information, the router, the default gateway, the DNS server, those those types of information. Default lease duration of 8 days, you can change that. Could take up to 8 days, 4 days before it tries to renew it. That's back to what if we're going to change the scope? Well, golly, first thing is shrink the lease duration so that your clients don't get to keep the addresses as long. Or you could go into all 800 of your machines and do an IP config, release, and renew. Configuring options, more options, creating reservations, and we've talked about those. The reservation is an address, a machine, you use the MAC address and the IP address, so I was going to get that address. To me, the issue with that is if the DHCP server dies, then your reservations don't get their reservations because there's no DHCP. Again, opinion, I'd use static addresses instead of reservations. So what's so tough about configuring a static address? Besides, if you use a reservation and the NIC dies and you go change the NIC on the server, if it's a static, you'll probably remember to put the new static address on, right? You going to remember to go change the reservation? Maybe. But you would have to because now it's a different MAC address. The net shell command, this is one that they have you do syntax for creating a DHCP reservation. These are some things that really are handy to practice. Are you going to have to use them on a regular basis? Yeah, probably not. When you actually do something in the field, are you going to have some help? Your friend and mine, Google? Sure. But if you have some idea of where you're going, it might make things work a little bit quicker. Client configuration, process on the client machine, fault tolerance in DHCP. The 80-20 rule, and this is something that they used to at least love to test on. What this says is let's have 2 DHCP servers in case one dies. Put 80% of your addresses on one and 20% of your addresses on the other one. And they're probably going to be on different networks. We actually have 2 DHCP servers sitting over there. One of them's never been started because the first one hasn't failed yet. Does it fail a lot? Now, is it going to be that big a deal to get things back up? I don't really think so, but it might be. And then we have backups. The DHCP servers by default back themselves up, back their database up every hour. So if you've got that someplace, you can get that. And you can actually restore everything by using its database. Log on, start up, proceed to exit. This is the client properties, general, display DHCP. This is the service, and it's an automatic starting service. Administration, monitoring the current state, and we've looked at the the console is about the extent, well, I won't say about the extent, it kind of is about the extent. You can, in the performance monitor, you can add some DHCP information that you can have come up in a performance monitor. And either you put it into a CSV file or just have it live to see what's going on. So you're going to add some counters to it, console statistics, and the console statistics, a broader range, comprehensive picture of the status of your DHCP server, what's going on, and scope statistics, information about each scope. If you run out of addresses, you're going to have, and I won't say what the symbol is because they change it occasionally, and I think the last one was a little blue symbol, a little blue dot by the addresses. You've run out of addresses. Check to see if you have addresses in your scope to give out. If machines all of a sudden aren't getting addresses, maybe you've run out. And you can go in and take them out. We had the list. We could remove those from the system. the audit log information, including what's going on, the host name, who got, what's going on with your DHCP server, what addresses were given to whom. Backup and recovery, automatic backup. The system automatically backs up the database every hour. You can do a manual backup if you want to do that. Store and percent system root, DHCP backup folder. So the location, you can change the location of that, obviously. Restoring it, you can restore the database from an offline backup when you're building a new DHCP server. The DHCP server died, and we were smart enough to back it up to a drive that's someplace else, not on that server. And we have the backup of the database. We can put the new DHCP server in, the new role in, and restore that database. So we'll have all of the addresses, whatever the last status was of that device. Restoring, backing up and restoring. Troubleshooting, you may have to occasionally reconcile this, and this to me is kind of a telling statement. Validates the DHCP database by comparing it with the registry values of the operating system to verify the database contains the most current data. We had at Blue Ridge some strange practices, one of which was to reboot every server on Saturday. Not always a bad thing, but with the new ones you probably don't need to do that. In T4 you do need to do that. But we would occasionally get this device with this really weird MAC address, which was about 2 times the normal MAC address, that would take all the addresses. And then people would come in on Monday morning and can't get an address because this strange device had all of them. Reconcile the database and says, not real. We'll throw all those away, and now people can get IP addresses. You may need to occasionally do that to get rid of stuff that shouldn't be there. That's just something that Is it tough to do? No, right-click, reconcile database. It's not a 10-minute operation. It's probably a 40-second operation. So it does work, though. Having had to use it, it does work.
7 to 10 minutes is from the time you start reading that.
Yeah, that's doing the click by click and say, looking back and forth. Oh, did I click it right? Determine the running services, the net start command at the command prompt. You can do that, or you can just look and see if it's running, look in your services. This is something that you do need to do sometimes if things aren't working right. Happened to me here earlier this week. I was looking at the WSUS. I said, something odd going on here because I haven't got any updates in a while. So I went in and tried to start the WSUS console and wouldn't start. Finally went to the services and went to the WSUS service, and it had not started on the last reboot. Sometimes services don't start. Sometimes you get this message, not all the services started. What that normally means is they didn't start in sequence. But it may mean that something really didn't start. You may have to go back and check this in the services. The net start command is what you use to start individual services at the command prompt or at the run line. And some of you may have seen me in the XP when we were doing Active Directory in the server class. If you look at your DNS server and you don't have your records for Active Directory, you can use the net stop. You can stop the net logon service. The net logon service is the one that actually loads the objects from Active Directory into DNS. You can use a net stop and a net start. Net start allows you to start services. Net stop DHCP Server or DHCP Client, depending on what you're doing, and then use a net start in order to start them. IP config, been there, done that, right? No need to talk about that. Release and renew. Display DNS is something also that can be very handy there. One of the things, and I'm jumping ahead of myself with DNS, is that if you get a bad lookup, it caches that just like it does a good address. And then you try to go again, it says, oh, you can't fool me, I just found out that was bad, it's still bad. It gets flushed a little quicker, but not that much. So I was able to talk a long time about a very simple process. It is a very simple process, but a very important process in your Windows or any type of network. Windows is not the only server that DHCP runs on, obviously, but we talked about leases, scopes, and options. How long do you want to make the lease for? Is there a right or wrong answer? There's a default 8 days or 6 hours, depending on whether you pick wired or wireless. Once you get it installed, you can change that lease time. I wasn't able to when I actually did the install itself. Communications process, remember DORA, initial lease request, lease renewals, changing subnet renewals. Remember DORA for discover, offer, request, and acknowledge for the DHCP process. Only DHCP servers in Active Directory domain need to be authorized. And if you're a standalone server in an Active Directory environment, it also won't work. If you're a member server, you need to be authorized in order for the service to start, because it does check to see if it's on the authorized list. And if it's a standalone, it checks to see if there's an Active Directory, and if there is, it says, oops, can't do this, not a member. Configure the scopes, clients to receive addresses, and there's lots of configurations. Don't just do, when you do the configurations, please don't just do the 3 that they ask you to do. Just see what other things are available in the DHCP configuration, because there's some different things out there. Performance monitor, to monitor it, to check the server. Are there questions? You're probably ready for a break, aren't you? Let's take a break.